Okay, so today we're going to integrate x to the power of 4 divided by x²+9 with respect to x. So polynomial on the top, polynomial on the bottom. So where are we going to start? Well, we can see that this one's to the power of 4, this one's to the power of 2. So it's looking like polynomial long division. So let's start with that. So polynomial long division. Okay, so how do we go about that? Well, let's do the setup first. So we've got x²+9 divided by x to the power of 4. Now, when we're doing the setup for this, we need to put all the different powers of the x in there just to help us out so we don't miss anything out. Okay, so with this x to the 4, we've got an imaginary 1 in there. So we can put a 1 there. And then we go all the other ones in there, all the way down to 0. So plus 0x³ plus 0x² plus 0x plus 0. And that way then we've got everything in there. Okay, right. So first of all, x to the power of 4. All we're interested in at this stage is this one here, x². So how many x² are in x to the power of 4? Well, to get that x² to get to x to the 4, we need to multiply by x². So therefore, we've got x². So let's put x² here. So we've got all the x² in line. And now what we do, we take this x² and multiply by this x²+9. So if we multiply x²+9 by x², we get x to the 4 plus 9x². Okay. And then what we do is just put a nice little bracket around these and subtract from the top line. So if we do that, what we'll end up with is x to the 4 minus x to the 4, that's 0. 0 minus 0, nothing to do. 0x² minus positive 9x² is minus 9x². Okay. And all these, we just leave those alone for now, that's fine. So now what we do is, for minus 9x², what do we have to multiply to get to x²? Well, if we take x² and multiply by minus 9, we get minus 9x². So going in the units column here, we go minus 9. Okay, so now if we multiply that by that, we get that. That's what we're looking for. So minus 9 times x²+9, we now put in this next column. So minus 9 times x² is minus 9x². Minus 9 times positive 9 gives us minus 81. So we put this in this one. So same again, same as we did here. Put this in brackets, don't forget the minus sign still in the brackets. And as we did before, subtract. So minus 9x² minus minus 9x², that will give us 0. 0, x, we could bring this all the way down. 0, nothing to write. 0 minus minus 81 gives us positive 81. Okay, so what we've got so far is x² minus 9, and this here is our remainder. So what we can write is, here is plus 81 over x²+9. That's our remainder. Okay, so now what we've worked out, that polynomial long division of this is the equivalent of x² minus 9 plus 81 over x²+9. And then if we just to be technically correct, we just put that in brackets. Then this is the same as this. So if you substitute a value for x, let's say 5, and plug all that in, and plug that into that one, you'll get the same answer. So we haven't changed the value of this. So now we've got some stuff here now which we can integrate. So x², we can integrate that straight off, power rule. Minus 9, we can integrate that straight off, that's fine. This one here, a little bit more work to do. So let's do the integral of x squared first. So the integral of x squared dx, or just simple power rule, that equals x cubed over 3. Add 1 to the power and divide by the new power. So that's 3 and then divide by 3. Integral of -9. So now we've got the integral. So put the minus out front. We leave the 9 in this time. Sometimes I like to leave the 9 out front, but for here we can just leave that in there. That's absolutely fine. So integral of -9 dx, that's just simply -9x. Okay, so that's that taken care of, that's that one taken care of. Now we got this one. So let's go integral 81 times 1 over x squared plus 9. Okay, so this is looking like an inverse tangent kind of option. So what we need to get for inverse tangent is x squared plus 1. So what we need is something in here, a u sub, so we can basically get to it to be plus 1. So let's just don't forget the dx there. So do the u subs down here. So if you let u equal, because we've got a 9, we want x over 3. Because then when we square it, we get x squared over 9, and that will be equivalent to this one. So u equals x over 3, du equals 1/3 dx, and therefore dx equals 3. Okay, it's 3 du, sorry, 3 du. Okay, right. So now let's do the u sub into here, bring it into the u world. So 81 times the integral of 1 over, now this is x squared. We want just for x. So what we can say is here, if u equals x over 3, x equals 3 times u. So therefore x squared equals 9u squared. So that's 9u squared. Plus 9, the 9 stays in there, that's important just to keep that in there. And then the dx, 3 du, very important to make sure we get the 3 in there. So we put that on the top, I put all 3 over 1, that way we don't get it all mixed up with all these. Okay, so 3, that can come out front, and then if you divide through by 9, that should help us out there. So let's bring the 3 out front, so that's 243. Integral of 1 over 9u squared plus 9 du. Okay, so that's taken care of that. So now we need to bring this to u squared plus 1. So if we just divide everything in here by 9, so therefore we get 243 divided by 9, which is 27. Integral of 1 over u squared plus 1 du. And as we all know, this is the inverse tangent. So just integrating with respect to u, we get 27 inverse tangent of u. But we want to be into the x world, so now we need to bring this back as an x. So what we know is that u is x over 3. So we can put that in there. That equals 27 inverse tangent x over 3. Okay, right, now let's just plug all these in, see what we got. So we can say that integral of x to the power of 4 over x squared plus 9 dx, that equals, so x cubed over 3 minus 9x, so that'll stay as a positive, so that's plus 27 inverse tangent x over 3 plus c, don't forget the plus c, and that is our answer.